This is Advanced Math, Unit 11, Lesson 3. And 11.3 we're going to title an ellipse. What is standard form for an ellipse? And then we will see some examples. Again, this should feel like review. You did this last year. The quantity of x minus h squared all over a squared plus the quantity of y minus k squared all over b squared equals 1. You will need to know this form because there will be questions on the test where they ask you to write it in standard form. You will need to know how to do this. And we'll go over that before. Okay, when it's written in this form, your center is HK. Your center is HK. And it just depends on the way, we're going to go over a graph in just a little bit, but sometimes your ellipse will open wider this way and sometimes your ellipse will open wider that way, like it'll be wider right and left or it'll be wider up and down. An ellipse is just a stretched out circle. These numbers are no longer the same. If these two numbers were the same, then you would be going right, left, up, and down the same distance, which would make it a circle. It's when these two numbers that are different that it makes it more oblong one way or the other. Okay, what we need to know about vertices. Vertices are always on the major axis. So your vertices could be running right and left, or your vertices could be running up and down. Okay, so from your center, you would go right a distance, left a distance, up a distance, down a distance. We'll talk about that in a little bit. Same thing, you'd go right, left, up, down. The vertices are always on the major axis, and the major axis are where your 2 points are furthest apart. Okay, vertices are always on the major axis. And again, the major axis are the 2 points that are furthest apart. So you can say the vertices are always the 2 points that are furthest apart. Okay, another thing we're going to have are foci. So let's say our ellipse opens oblong this way or oblong this way. The foci are always on the major axis. So let's say this is the center and your major axis is running right and left. Your foci will always be on the major axis, equidistant from the center. So you go right and left the same length. Let's say your major axis is running up and down from the center, then your foci will always be on the major axis. Okay, so let's write that down. Foci are always on the major axis. Okay, and always inside the ellipse. You need to know that as well. They're never going to be, you're never going to move right and left a further length than your vertices. So you would never from the center go right and then left and end up outside of your ellipse. They're always going to be inside. Okay. Focal length. Focal length, your formula for your focal length is c squared equals the absolute value of a squared minus b squared. We put absolute value because there is a chance that the b squared value might be larger than the a squared value, and when you subtract, you don't want it to be negative. So we take the absolute value because we will be square rooting both sides to find c. All right, so let's go ahead. Oh, before we graph really quick, you also need to know what eccentricity is. Eccentricity is c over a or c over b. C being your focal length divided by your a value or your b value. How do you know which one to use? You always use the larger one. So A or B, you use the larger value. Okay, we'll talk about it as we go. You should know that eccentricity is always between 0 and 1. It's never going to be smaller than 0 or bigger than 1. Eccentricity is between 0 and 1. Bigger than 0, smaller than 1. What you do need to know, we will review this before the test, is the smaller the value, the closer your ellipse is to a circle. It's more circular. It's not a circle, but it's going to be more circular. Your eccentricity is, it's going to be more oval. It's going to be more stretched out. Okay, now we can see an example. Find the center, vertices, foci, eccentricity, and sketch. I'm just going to put sketch and then we'll list all the things we have to find. Number 1, the quantity of x minus 2 squared over 9 plus the quantity of y minus 1 squared over 4 equals 1. Center, C for center, V for vertices, F for foci. There's going to be 2 vertices and 2 foci. And then E for eccentricity. All right. First thing we need to do is find our center, opposite of the inside. See how center was HK, opposite of H, opposite of K. So positive 2, positive 1. Opposite of negative 2, opposite of negative 1. Okay. Vertices, we are going to have to sketch. Eventually you can do without sketching. You can kind of just see it and work through it, but for now we're going to sketch. First I'm going to find my A and B values. My A, if A squared is 9, then A is 3. If B squared is 4, then B is 2. Does everyone see how I got A is 3 and B is 2? Square roots of the denominator. A is with the x value, B is with the y value. Okay. Center, center is 2, 1. So I go over 2, up 1. And then the A value tells me how far right and left I'm going to move from the center. And the B value tells me how far up and down I'm going to move from the center. I just think of it as A is with the x. Whatever's underneath the x tells me how far I'm going to move in the direction of the x-axis, and that's right and left. Whatever's with the y, which is the 2, tells me the direction I'm going to move in on the y-axis, that's up and down. Okay, so from the center I'm going to move right and left 3. 1, 2, 3. 1, 1, 2, 3. And then I'm going to move up and down 2. 1, 2, 1, 2. And then you make your ellipse. And it'll look nicer when it's on actual graph paper. Right now mine looks a little off, but we're hand drawing our graph paper, so it does make a little difference. Okay, there is our ellipse, our oval shape. Okay, vertices. Remember we said vertices are always on the major axis, and your major axis is the larger axis. Here's my major axis. Here is my minor axis. Again, major axis, minor axis. Okay, vertices are the 2 points that are furthest apart. That's these 2 points here. I originally went over 2, up 1, and then from there I went right and left 3. 2 and then 1, 2, 3, that would put me at 5. And then left 1, 2, 3, that would put me at negative 1. Okay, so this one here is negative 1, 1. This one over here is 5, 1. Do you see how that works? Right, left, 5, 5, 1, negative 1, 1. Now the foci, don't draw this yet because I'm going to erase. The foci is going to be in here somewhere. We're not exactly sure where, but we know it's going to be inside on the major axis. Now think about it. When I'm moving right and left, the x values are changing, but the y value will stay 1. You see how it's 1, 1, and 1? So when I find my foci, I know the y value is still going to be 1. It's the x value that will be changing. Now if it had been longer up and down, and I'd be moving up and down, it would be the y value that would be changing, and the x value that would stay constant. Okay, I'm going to find the focal length. C squared equals the absolute value of a squared, which is 9, minus b squared, which is 4. I don't use a and b, I use a squared and b squared. A is 3, b is 2, a squared is 9, b squared is 4. C squared equals 5, square root, c equals the square root of 5. And we don't put plus or minus because we're looking for length, and length is positive. Okay, so I'm going to move to the right 0.5, to the left 0.5. 0.5, I'm sorry, not 0.5, root 5. Root 5 is slightly bigger than root 4, and root 4 is 2. So if you were to plug it in your calculator or do it in your head, you can estimate it's a little bigger than 2. And I'm going to plug it in the calculator. I don't know if you can see that. It doesn't look like you can, maybe. 2.2. All right, so I'm going to move right 2.2 and left 2.2. Okay, so I moved right and left, and I'm just going to leave it as root 5. I'm not going to put as a decimal when I write my answer here, just when I was graphing, because when you're graphing, it's easier to graph a decimal than it is a radical. Okay, so what are my foci? There's 2 of them here. From the center, I moved right root 5 and left root 5. And I stated earlier, when I'm moving right and left, it's the x value of the center that is changing. So from the 2, I went right and left root 5, plus and minus root 5. And as I stated earlier, the y value stayed the same from 2. And if you were to plug that in your calculator, you would do 2 plus 2.2, which would put you there, and then 2 minus 2.2, which would put you there. But we write it like this on our answers, and we plug it in and do decimals when we're graphing. Okay, eccentricity is C over A or B over A. Let's see which one's larger. A is larger because that's the one we're supposed to use, a larger value, and C is root 5. So it is root 5 divided by 3. Plug that in your calculator. I already have root 5 in my calculator, so I'm just going to divide by 3. And that gives me 0.7453, blah, 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 blah. I'm going to round that to 2 decimal places, 0.75. And if you have your calculator, you can plug it in yourself, 0.75. And yes, you have to change it to decimal form. All right. Oh, and as we stated, the eccentricity will always be bigger than 1. I'm sorry, bigger than 0, smaller than 1, and 0.7 is indeed between 0 and 1. Okay, that's it for this problem. We're going to move on. Number 2, I want you to write in descriptive form or standard form. Write in standard form. X squared minus, plus, and I'm going to erase that or white it out, x squared plus 4y squared minus 6x plus 20y minus 2 equals 0. X squared plus 4y squared minus 6x plus 20y minus 2 equals 0. So again, when they ask you on the test, and you will have a few questions where all they ask is what is the shape. You do not have to rearrange, you do not have to rewrite. You look at your 2 squares. As long as there's 2 squares, it's not a parabola. There's 2 squares here, and the leading coefficients are not the same. This one's positive 1, this one's positive 4. As long as they're both positive or both negative, as long as they're not opposite signs and the leading coefficients are not the same, then it's going to be an ellipse. We'll talk more about that. Really quick over here, remember what I said about these two numbers being different, because if they were the same, it would be a circle. You can see that here. Because I moved right and left 3 and up and down 2, it's longer one way than it is the other. If these were both 9, then I would go right 3, left 3, up 3, and down 3, and that would be a circle. So these being the same is what makes it a circle. These being different is what makes it an ellipse. Okay, so descriptive form works very similar, or standard form works the same as what we were doing for circles. Let's rearrange. X squared minus 6x plus 4y squared plus 20y equals, move the 2 over because it's kind of just in our way, equals 2. All right, I'm going to complete the square here and here. Because there's two squares, an x squared and a y squared, I do have to complete the square twice. X squared minus 6x plus blank plus, before I can complete the square on this one, I do have to factor that 4 out. Not 4y, just the 4. Y squared plus 5y plus blank equals 2 plus blank, because there are 2 blanks here where I'm completing the square. Alrighty, so we're going to take 6, cut in half, and square it. That gives me 9. And what I add to one side, I must add to the other. Take 5, cut in half, and square it. It's a fraction, do not change it to a decimal. 5 over 2 squared is 25 over 4. I'm hoping everyone can see that. 5 over 2, 5 cut in half, that's what we did here. Negative 6 cut in half is negative 3, squared is 9. 5 cut in half is 5 halves, squared is 25 over 4. And then don't forget, you do have to multiply by the number on the outside, and 4 times 25 fourths is just 25. Okay, so let's go ahead and factor. Double bubble, x minus 3 plus 4, double bubble, y plus. You pretty much look at negative 6 divided by 2 is negative 3. Positive 5 divided by 2 is 5 halves. It's always half of the middle number. 5 halves times 5 halves is 25 fourths. And 5 halves plus 5 halves is 10 halves, which is 5. So it does work. If you didn't get that, put pause, double distribute, and see if you end up with this. Okay, and this side is 36 once you add all that up. X minus 3 quantity squared plus 4 parentheses y plus 5 halves quantity squared equals 36. Okay, so here is where you ask yourself, is it a circle, is it an ellipse on your next step? If it were a circle, you would stop. That 4 wouldn't be there, and you would stop. If they both had a 4, you would divide the 4 over to this side, and you'd be done. Since it is not a circle, it is an ellipse, it has to equal 1. Circles do not have to equal 1. They can if your radius is 1. But with an ellipse, it has to equal 1. So we have to divide everything by the 36. Which gives us x minus 3 quantity squared over 36 plus 4 and 36 reduce. 4 is 1, 36 is 9, leaving y plus 5 halves squared over 9 equals 1. X over 3 squared over x minus 3 squared over 36 plus the quantity of y plus 5 halves squared over 9 equals 1. Okay, and we will do one more together when we get in class. There is one more we will do. This is it for now.